You know that nightmare scenario for any AV tech, right? You've got this massive venue, the projector's 100 feet away.
Oh, yeah.
You run the copper, plug it in, and you get snow.
Right.
Or, just a black screen.
It's the classic battle. Distance versus bandwidth.
Oh.
And usually physics wins that one.
Usually. But today we're looking at a piece of kit that claims to, well, cheat physics a little. We're doing a deep dive into the Kramer HDBT7-OUT2-F16.
It is a bit of a mouthful, isn't it?
It is.
But for anyone running a VS1616 series matrix switcher, this isn't just a card. It's the engine room. It's a 2-port output module designed to push these high-bandwidth signals way further than standard HDMI ever could.
Right. And just to be clear for everyone listening, this isn't some standalone box you can just buy.
No.
It has to slide into that specific modular chassis.
Yeah.
But the headline feature here is HDBaseT. We hear that term thrown around all the time. In this context, what is it actually doing for us?
So think of HDBaseT as the everything pipeline. I mean, instead of running separate cables for your video, your audio, power, control signals, right? This card basically condenses all of that onto a single twisted pair category cable. Just a standard Ethernet cable, really. The goal is simplicity.
Simplicity is great, but let's talk limitations. I was looking at the spec sheet for this, and there's a massive discrepancy in the range. It says it can hit 70 meters. That's about 230 feet. But then right next to it, the limit just plummets to 40 meters or 130 feet. That's a huge drop-off. Why?
It all comes down to data density. That 230-foot range, that's for 1080p video, even with 12-bit deep color.
Okay.
But the moment you jump to 4K, you're trying to shove 4 times the number of pixels down the exact same copper pipe. The card has a maximum data rate of 10.2 gigabits per second.
And that's the hard limit.
That's the limit. So to keep that 4K signal stable, you just have to shorten the leash. It's physics.
And this is where I saw that one spec that, always trips people up. 4K 60, 4.2.0. Why is that 4.2 point part so important here?
Yeah, that is chroma subsampling. It's essentially a compression trick. To fit 4K video moving at 60 frames per second into that 10.2 gigabit pipe, the card has to discard some of the color information.
Okay, so what is it keeping?
It's keeping all the brightness data perfect. That's what your eye notices most. But it's compressing the color detail.
So if I'm an installer, I really need to know that. If my client is, say, a Hollywood colorist who needs perfect 4.4.4 color accuracy, this card might struggle at those distances.
Exactly. If you need that 4.4.4 color at 4K, you're then limited to 30 frames per second just to stay within the bandwidth. It's always a trade-off.
There was another caveat in the documentation I wanted to ask you about. It says these ranges are only guaranteed when using Kramer HDBaseT cables. Is that just a sales tactic to sell more wire?
You might think so, but at these frequencies, cable quality is, well, it's everything. We're talking about high-frequency signals that degrade incredibly fast.
So a cheap cable won't cut it?
Not a chance. If the twist rate inside that copper isn't perfect or the shielding is weak, you won't get 130 feet. You might get 80. So while you don't have to use their brand, you absolutely need a high-spec shielded cable to make it work.
Okay, so we've got the good cable. We're within range. How does the signal actually survive the trip? This card lists something called Kramer equalization and reclocking.
Oh, yes.
Sounds like fancy marketing speak for it works well.
It's actually pretty distinct engineering. So imagine the digital signal as a perfect, crisp, square wave.
Okay.
Over 100 feet of copper, that sharp square gets fuzzy. It gets rounded. That's jitter. Reclocking, with a K, of course, means the card strips that messy signal down and completely rebuilds the timing from scratch before sending it out. It's like rewriting a messy note so it's legible again.
That makes a lot of sense. And since it's HD-based, it isn't just video we're rewriting and sending, is it?
Correct. This card also supports bidirectional RS-232 and IR, infrared.
And in plain English?
It means you can point your remote at your source device in the equipment rack, and that command travels down the line to turn on the projector 130 feet away, or the other way around. You get full control without running extra wires.
Which is a huge labor saver on an install.
Huge.
Now, looking at the practical side, it's a small card, 19 by 13 centimeters, and pulls only 8 watts.
Which, it's negligible in a rack environment. Very efficient.
Price-wise, we're looking at about $3,024 today, down from a list of around $1,280. For a dual output card, that seems to be the going rate for this kind of professional reliability.
Yeah, you're paying for the peace of mind that the 4K signal actually arrives and doesn't turn into digital confetti.
But that brings me to a final thought. We talk about that drop from 230 feet down to 130 feet just by moving from 1080p to 4K.
It's a steep penalty for resolution, for sure.
It really is. And it makes you wonder, we are pushing 10 gigabits through copper now. As resolutions climb higher to 8K and beyond, are we finally hitting the physical wall of what copper cabling can even do? Are we approaching a future where copper just becomes obsolete for long runs? Something to think about the next time you're pulling wire through a ceiling. Thanks for diving in with us.